Hi, my name is Vipin, and this is a short tutorial on what Gurobi optimization is and how to use it. So for a quick overview of this tutorial, I'll start by explaining what Gurobi is, give you a quick overview on how it works, give some examples of how it's used in the real world, explain the standard framework that will allow you to solve problems with Gurobi, and then I'll walk you through how to download the Gurobi Python API, which is all you should need for the foreseeable future, and then explain how to implement the standard framework to solve classic puzzle of Sudoku before ending off with how this is applicable to financial problems. So what is Gurobi? Gurobi is a mathematical optimization tool developed using techniques from operations research that allow you to solve different problems, including linear programming, which is when you either maximize or minimize a system of linear equations with a set of linear inequality or equality constraints over a continuous set of variables, or MILP, which is similar to linear programming, but the variables can either be integers or continuous. And then the last one I'll touch on is quadratic programming, where you optimize a quadratic function that is subject to linear constraints. There are several more that are listed here and that aren't listed on the slide, but these are the major types of problems that you'll be able to solve with Gurobi. Without getting too into the weeds about the specific mechanisms that allow Gurobi to work, the general techniques that Gurobi employs are branch and bound, where it represents the set of assignments as a tree and will traverse this tree by completing some bounding to determine what branches to explore in order to find an optimal solution. Then the next is cutting planes, which will first relax integer constraints by letting them take on continuous values. And then it'll solve this new formulation of the problem and check for integer solutions. And then if there is integer solutions, the program will terminate. And if there isn't any integer solutions, it'll cut out the current non-integer solution and repeat this process until it determines the best integer solution or finds that no such feasible one exists. And lastly, there's heuristic methods, which Gurobi uses to a lesser extent in order to approximate solutions to these models. I didn't go into great detail about these, but there's a lot of information online about how these algorithms work if you're interested. Now at this point, you might be wondering if Gurobi is just a niche tool solely used by academics to solve unrealistic problems, but this couldn't be further from the truth, as massive companies such as Capital One, Amazon, Apple, Marriott, FedEx Ground, and certainly much more are big customers of Gurobi. And for specific examples of Gurobi being used in the real world, the NFL uses it to generate their entire schedule for the year, and then the US Census started using it in order to mathematically ensure certain levels of privacy and anonymity within the data they release. DoorDash uses it along with some supplemental machine learning to improve their routing, and Air France uses it to find optimal flight assignments subject to the many constraints involved in flying hundreds of planes across the globe nonstop. So when solving a problem with Gurobi, the typical and standardized framework that is used is to first create our model, which in Python will be by writing the lineup in the first box. Next, we'll need to initialize our variables, which we'll call decision variables, and we'll use add_vars for this, where we can control UB and LB, which are our lower and upper bounds, OBJ, which is our objective coefficient, which is similar to a weight for how important this is for our objective function, VType, which is our variable type, and can be continuous, which is like ranging over the real numbers, binary, integer, semi-continuous, or semi-integer. And note that semi-continuous and semi-integer are different than continuous and integer, as it can either be 0 or in a specified range. Whereas if we just slap a lower and upper bound on an integer type, that doesn't include 0, and it can never be 0 if it's outside of the range. So then the next step is to add our constraints, using add constraint, where we pass in a constraint and a name, and some of the constraint types included are a linear constraint, and a quadratic constraint, and also a Boolean constraint, as you can see. This highlights the importance of choosing the right variable types for your problem and just how flexible Gurobi really can be. And the last things you'll need to do are to pass in your objective function to set objective and choose to either maximize or minimize it using grb.maximize or grb.minimize. And then you can optimize the model using model.optimize. And keep in mind that having an objective function can be optional, as we'll see later when solving Sudoku. So the steps I included on this slide are specifically for the Gurobi Python API, which is relatively simple to download. So we'll start by opening your favorite Python editor, and in your terminal write pip install Gurobi Py. After this, you'll want to go to Gurobi's website and create an account with your academic email. Next, to get the academic license, you'll want to be on an academic Wi-Fi network, such as like the CMU New York network. And if the one you're on doesn't count as an academic network from Gurobi's perspective, then you'll need to use the CMU VPN and tunnel all of your traffic through it. And then after this, you should have an academic key, which if you write the command on line 5 in this into your terminal, then you can get basically unrestricted access to Gurobi. And you can use it in any project you'd like by writing the 2 import lines included later in the slide. So for the example I'm walking you all through, I wanted to choose an example that people commonly solve with other tools such as backtracking and sat solvers and show that it is possible to solve it in Gurobi. I'm not going to include all of the code that is involved with reading a given board or some of the other non-essential tasks with this, but I'm just going to focus on the process of taking a constraint of the game and translating it to Gurobi and then being able to solve it. So to begin solving Sudoku, we'll first need to create our variables, and we automatically know that continuous variables, so variables which range over the real numbers, aren't going to work. And this is because Sudoku entries can only take on integer values. But dealing with integer values as integer types in Gurobi might be a little bit problematic for this, so we'll just settle for using binary variables, which will end up producing the cleanest solution. So we'll transform the following constraints into a Gurobi model, which is ready to be solved in the upcoming 2 slides. So as shown on the framework before, we'll need to start by initializing our model as Sudoku solver. And then next, we want to define our variable as binary and using the indices of n, n, which as the comment indicates can be indexed into as vars ijk, where ijk are just the range from 0 to n. And Gurobi will handle all the work by creating the Cartesian product of these indices, and this will be our entire set of variables. So to deal with our first constraint, it's clear that every single cell in Sudoku needs to have only one entry, usually in the range from 0 to 9. So we'll start by enforcing this by adding constraints using a generator with the k index being the wildcard. Then it's a nearly identical set of lines for the next 2 constraints of enforcing that each number from 1 to n appears once in every row and every column. So the next constraint we need to deal with is that each value has to appear exactly once in each of the 3x3 subgrids across the board. And we can enforce this using the given constraint on the code there, which makes use of quicksum. And then we can be ready to optimize our model and use it to generate a solution board for Sudoku. Now, the other line that I want to draw your attention to is line 19, where there's a check included for if the variables are greater than 0.5. And this is because although Gurobi's binary type is only supposed to include the values of either 0 or 1, the methods Gurobi uses does allow for floating point errors. But we can easily deal with that in the case of binary variables just by checking if it's greater than half. And that will be enough to solve Sudoku. So after all of this, you might be thinking, great, but I'm here to learn computational finance. To which I'd say that Gurobi is used by banks and quant firms around the globe to manage over 12 billion euros of assets. The typical use cases for Gurobi are to optimize portfolio holdings by minimizing things such as variance, transactions, and risks, maximizing gains, returns, and utility, while making sure that you aren't violating any thresholds for transaction costs, certain monetary regulations, liquidity, and doing so for your given risk profile. Some of the links that I gathered throughout making this tutorial that I thought were useful for finance specifically are these 3 that I've included right here. So thanks for sitting through this tutorial. I included my email in case you guys have any questions. Although I'm still relatively new to using Gurobi, I'll try my best to help you guys. Thank you.